AnalyseGE is a tool that you can use to look in detail at simulation results, simulations that you've carried out using RunGTAP. And this is the introduction to how you can use that tool, AnalyseGE. Here I've just carried out a simulation with RunGTAP, and you can see I have a nice smiley face on the accuracy summary, and then I click OK here. At this stage normally you would look at the results with the Results tab, but in this case I want to show you how you can use AnalyseGE program to delve further into the results and see how these results are consequences of the data and the equations of the model. I've loaded an experiment that's been solved here, this experiment TMSEUFG. Experiment is the complete elimination of the bilateral import tax on food from sub-Saharan Africa into EU using Gregg's method. And now I have the results. If you want to use AnalyseGE to look further into these results, you click on the View menu, and right down the bottom is View the Results using AnalyseGE. Then just click, and the program AnalyseGE will start to run. I hope. Here it comes. This program will load the solutions, load the information from the solutions. It knows all the values of all the base data. It also is able to extract the Tableau file for the model from the solution file. It'll then, as you can see from the red status remark here, is running Tableau to check the tab file. And then here you can see it's reading the solution and some file called the SLC file, which gives it information about all of the base data. And then after a few false starts and so on, it brings up a couple of windows. There are actually, as you will see, 3 windows associated with AnalyseGE, and let me make this one full screen. And this window looks awfully like TabMate, so that you can work in this window just like you do in TabMate to search for various variables, use glossary and so on. Once you've loaded this, you can carry on with analysis, as we'll show in the examples that follow. So let's begin to use AnalyseGE to look at and analyse the results of this simulation. First thing I suggest we do, search find for the variable which has been shocked, namely TMS. Click OK and cancel to remove this search window, and click in the variable TMS. Having done that, I can right click, brings up a menu, and let's just do evaluate this variable. This puts us into a view-har window where we can see the results, and the results that we're interested in, all commodities from all regions being imported into the EU. And you can see, sure enough, that food from sub-Saharan Africa is given a shock of minus 11.5%, and all these other shocks are 0. We're not doing anything else to other commodities from sub-Saharan Africa or to any commodities from the rest of the world. Let's go back to TabMate, and you can do that by the front menu. Bring TabMate back to the front. And now a very useful feature of AnalyseGE, it's really a feature of TabMate, is that when you click on something in the file, in this case TMS, if you click on the glossary button, we can find all occurrences of that expression. So if I click here, I can see all occurrences of the variable TMS in the model, and I want to see the equation that involves TMS, and it's this market prices equation at line 1707. If you click on 1707, you can bring up that equation. I'll just come down a little bit so you can see the whole of the equation. This equation, market prices, shows how shock to TMS, the tariff, gets transferred through to the variable PMS, which is the market price. So if we look here and click on PMS and then right click and evaluate, we can see what happens to the market price of imports, PMS, the M's there stands for imports, so we're interested in food from sub-Saharan Africa into the European Union. And you can see that the imported price of food from sub-Saharan Africa into the EU only falls by 9.7%, even though the reduction in the import tariff was 11.5%. Let's go back to TabMate and see if we can see why that is the case. Let's look at the terms on this equation. We've seen the minus 9.5 here. What about this TM? Well, the colouring tells you something already without having to evaluate it. The fact that it's red means it's exogenous. The fact that it's italic rather than bold, see TMS is bold, that's because TMS has at least one component shock. Going back to TM, the fact that it's not bold but just italic means it's not shock. So this is exogenous and not shock, which means all the values must be 0. So the difference between the imported price, PMS of minus 9.5, and the TMS shock minus 11.5 must be, in this other term, the CIF price. So the CIF price of food from sub-Saharan Africa into the EU. To check that, we could look at the CIF prices, but what I suggest you do instead is to, while I'm still clicking on this equation, right click and choose a second option, decompose part of this equation. You get some options, but they're usually the right ones, so just say OK. And now let's focus on food again from sub-Saharan Africa into the EU. And sure enough, we get a decomposition. This confirms that the TM value is 0, the TMS we know is minus 11.5, and lo and behold, the CIF price must have increased by 2.1%. And that's why, and the total of these things is pretty much the same as what's happened to the import price PMS. Now let's go back to TabMate. And so you can see now that we understand how this shock is transferred to the imported price of food from sub-Saharan Africa into the EU. Obviously, somewhere else it would be good to analyse why the CIF price has gone up, and that's something you could analyse separately. We've seen that this shock reduction on the import tariff has reduced the price of imported food within the EU from sub-Saharan Africa. And what I'd like to look at now is the effect this has within the European Union. First of all on food, and then indeed first of all on imported food. To do that, let's get to the top of this file, which you can do by grabbing this and pulling to the top of the file, clicking somewhere there, and let's find for the variable which denotes the price of imported food into the EU, that's PIM. We'll also look shortly at the associated quantity QIM. Click OK and remove this search window. Here we have the variable PIM, click on it and right click to evaluate. And here we see, you'll notice that I've switched to 2 decimal places. You can move back and forth within the ViewHar window, for example if you want 1 decimal place, or as I prefer to have now 2 decimal places. We can see that the price of imported food in the EU has fallen by about 0.58 or about 0.6%. Rather a small fall considering that the price of imported food from sub-Saharan Africa has fallen by some 9.6%. Let's see if we can figure out why the overall imported price of food in the EU has only fallen by this relatively small amount, 0.6. So bring TabMate back to the front. And now in order to understand the PIM values, we need to find an equation that explains that variable. We can find all the occurrences of PIM, remember, by this wonderful gloss button. Click on that, and there indeed rather a lot of occurrences of PIM in this model, and I think the equation that we're looking for is somewhere down the further down. Now, an equation that explains PIM is an equation that probably has PIM on the left-hand side. And if you look here, I can tell you that one of them is this equation D price imp. You can see here that PIM is on the left-hand side. So let's click on this red number 1753 to the left and go to that equation. Here we have the equation D price imp, which explains the values of the variable PIM. You can see that PIM is a sum across all regions of some term, some term. And this is a term which involves things like food from some region, like the rest of the world or sub-Saharan Africa, into the European Union. Having selected that term, if I right-click, I can evaluate the whole expression. And it tells me I didn't quite select the expression correctly. I left out this bracket at the end. Let me include that, and now right-click and evaluate. We've got food from sub-Saharan Africa into the EU. Let's this time look at food from all regions into the EU. And now you can see the contributions. The contribution of food from sub-Saharan Africa is about minus 0.4%. The contribution of food from the rest of the world is about 0. And there is a contribution of food from the EU to itself. That really means food imported from one country within the EU to another country within the EU. And that gives a total of about minus 0.48, which is about the fall in the overall price of imported food. So the main player in this game, as we expected, is sub-Saharan Africa. But although the price of imported food from sub-Saharan Africa into the EU fell by some 9.6%, the flow through into the overall price of imported food in the EU from that is only 0.39. Why is that so small? Let's go back to TabMate and we can see. So now each of these terms is made up of two parts. This M share S, which is a share, and then this PMS minus AMS. Now first of all, we can dispense with AMS. Remember, it's red, that means it's exogenous, and it's italic, that means it's not shock. So we know those terms are 0. So these contributions are really shares times PMS's change in the imported price by source. Let's have a look at these M share S values first of all. Click on them and right click to evaluate. Now we're seeing food from all regions into the EU, just what we want to see, and now this begins to tell us something. Only 0.04, see that first of all that the shares all add up to 1 as you would expect. Only 0.04, that means 4% of food imports into the EU come from sub-Saharan Africa. 25% of food imports into the EU come from the rest of the world, and lo and behold, 71% of food imports into the EU come from the EU itself, come from some other country in the EU. And that begins to explain why the rather large fall in the price of imported food from sub-Saharan Africa into the EU has had such a small effect on the overall price of imported food into the EU, because sub-Saharan Africa is such a small player, relatively speaking, in that market. It only has 4% market share. Let's go back to TabMate. This bundling together of food from the different regions, imported food from the different regions into the EU, is done in a CES nest. We've just been looking at the price part of that CES nest, and just below that in the tab file as you can see if you click down, is the quantity part of that. So this equation, import demand, is the equation which explains how much imports of food from the different regions into the European Union change. That's the variable QXS, percentage change in the quantity of, well, exports of food from various regions into the EU. Let's just have a look at the QXS values to see how big some of these changes are. Right click, evaluate, and looking at food from all regions into the EU, the spectacular result is that, sorry, I shouldn't have clicked there, imports of food from sub-Saharan Africa into the EU go up by 56%, whereas imports from the rest of the world into the EU fall by 1.9%, and imports of food from EU back to itself fall by 1.4%. So indeed there is a big change in the imports of food into the EU from sub-Saharan Africa. Let's go back to TabMate and have a look at that a little more closely. This equation is typical of the CES nest. There's an expansion term, QIM, that's the percentage change in the quantity of imported food in the EU, say, and then there's a substitution term, this term here. It's made up of an elasticity, E sub m, times, well, in the levels a ratio of prices in percentage change terms, the difference between two prices. Difference between the price of food from region R compared with the average price of food coming into the EU from all sources. When you have a CES nest like this, it's often very useful to see whether it's an expansion effect, this 56%, or substitution effect, and so let's right click and decompose part of this equation. Again, this is the right form, and now focusing on food imported into the EU. And let's first of all look at food from sub-Saharan Africa. We can see, I'll mention the AMS term in a minute, but this is the expansion effect, 0.71. So the quantity of food, percentage change in the quantity of food imported into the EU is only 0.7%, not very spectacular. But the contribution of the substitution term for food from sub-Saharan Africa coming to the EU is 42%. Now let's bring back all regions, and you can see that the expansion effect is the same for all regions, but the substitution effect is quite different. The price of food coming from sub-Saharan Africa falls markedly with respect to the average price because the import tariff has been removed. On the other hand, the price from the rest of the world, of course, stays the same, and so is then higher than the average price, and that means there's a correspondingly negative substitution term, and that's why imports of food from the rest of the world fall. So let's go back to TabMate. And then from these two equations we've seen how the price of imported food in the EU changes, falls by about 0.6%, and how the quantity of imports of food from sub-Saharan Africa into the EU rises so dramatically. We saw that it rises by some 56%, and that's mainly because of this substitution term. Let's have a look at first of all the price difference. Evaluate and do it for food from sub-Saharan Africa into the EU, and you can see that this price difference is 9%. Then how do we get the 56% change in imports? Well, it must be because of this elasticity, and so let's have a look at that for food. And we see that the elasticity is about 4.5, and that's how the 56% comes about. This is about 4.5, and this is about 9, and 4.5 by 9 is something like 56%. It's time that I explain to you that the equations in the analyzer, when you're looking at them and when you've taken an accurate solution, the left hand side and the right hand sides are often not quite the same as we're seeing in this case, but they're usually about the same order of magnitude, and the equations are approximately satisfied, certainly accurately enough satisfied to let us say whether the expansion effect, the QIM term, or the substitution effect dominates. Lastly, I've been ignoring all these red terms, these AMS terms. In the analyzer, red italic means that the variable is exogenous and not shocked. That means, as far as we're concerned for this analysis, it has the value 0. So that's why I've been ignoring the AMS term there and the AMS term there, and why I also ignored the AMS term when I was looking at the price of imported food. Well, that completes this introduction to AnalyseGE. In this introduction, I've worked through the first parts of analysing this simulation in which imports of food from sub-Saharan Africa into the EU have their tariffs reduced considerably. I've been following a paper which you can download at the same time as you downloaded this AnalyseGE demonstration, and that's this paper, AnalyseGE, Software Assisting Modelers in the Analysis of Their Results. In the AnalyseGE introduction that you've been listening to, I've worked through sections 3.1 and 3.2, and I suggest now that if you want to learn more about AnalyseGE and also about the GTAP model, you download this paper and work through the rest of our analysis of this application, which is sections 3.3, 3.4 and 3.5. You'll see there are a couple of puzzles there, puzzles which the AnalyseGE tool helps you to understand. In this paper there's also a second application, another slightly more advanced GTAP application in section 4, and you might like to work through that as well. Thanks for listening to this introduction to AnalyseGE. Happy GTAPing and happy AnalyseGEing.